This has been a journey. If you were here last year, May-ish time frame, I did a presentation. Oh, I'm sorry. David, are we on? We are on. If you were on our YouTube channel, make sure you like and subscribe for the great content we have going on. We need our subscribers to go up to over 1,000. That way we can actually monetize our channel and get some funds into the organization. So like and subscribe, all of you too as well. But with that, I've been on a journey. What was it, beachfront property, right? When Orangevale was beachfront property, we had that presentation last year. And that was my initial endeavors into researching these crazy Native American stories, tribal traditions that I had found. And I was like, why hasn't anybody ever researched these? They just discarded them or threw them aside because they were just too far-fetched, or what was the deal? So I gave a little research on especially the historical sources I had found last year, which I won't go into today. Today is really an update on what I've found since then, which is, I'm not going to be able to cover everything because I'm in the process. I'm in chapter 1 of the book. I'll be writing a book on this because just so much material. It's covering so many areas of science, archaeology, anthropology, and everything. It's crazy. I can't even think of how many papers I've read, journal articles, research papers, geological journals. Oh, and I've learned a lot. I'm going to tell you, it's been pretty crazy. So with that, we'll go to the introduction. For those that weren't here last year and didn't watch it on YouTube before tonight to get themselves up to date, there was one specific oral tradition that got captured by a gold rush memoir. This gentleman in Yerba Buena, the predecessor to San Francisco, he had captured this story from an Indian who worked for Richardson, Captain Richardson of Richardson Bay fame, if you know where Richardson Bay is. And Captain Richardson liked to hear this name, this Indian's name is Monica. So he would say, hey, Monica, tell us that story again from your ancestors. It's like, well, way a long time ago in human memory, the Golden Gate was a mountain range. It was blocked. There was no Golden Gate Strait. All the water from the Great Valley ran down the San Francisco Valley through the Santa Clara Valley out into the Monterey Bay. And in a convulsion of nature, there was this huge earthquake and the Golden Gate opened up. The water started draining out the Golden Gate and the Santa Clara Valley was uplifted. And so at that point it dried up and that's what you have today. And they were all like, wow, that's pretty cool. And of course I had never heard anybody research this, validate it, disprove it, anything like that. So I was just like, wow, that's crazy. So that's what I've been doing for the last year. Yeah, it's been about a year I've been working on this. With that, I had found other stories. We had the Maidu flood story that maybe some people are familiar with that came out of the Powell stuff. I looked through the historical records. We had a story from the Loweto village that's just near Puda Creek on the west side of the valley. They talked about the valley used to be a big lake. Their ancestors told them it was a big lake. And so again, human memory, we've got a big flood from the Maidu. The entire valley filled up. The big man kicked open the mountains and let the water drain out of the valley. That was the story, right? And from the Maidu, the Loweto just said it was a big lake. And then the Carquinez Straits opened up, the Golden Gate opened up. And I found in the Bancroft histories, they talked about the Golden Gate being opened up. There's quite a few references in the records back then of these stories from the local tribes about this big lake in the valley, the Golden Gate being closed. And so I was like, wow, there's got to be some sort of geological, archaeological evidence to say why, if this actually happened or not. Because it seems like there's a lot of stories going around and nobody's really taken them seriously from what I could tell in the scientific community. So I went through the historical records. Again, I found Bancroft, I found all the different explorers. I went through all that data. I checked out the Manila galleons, which cruised by San Francisco Bay, the opening, for 250 years and never saw it. And then the explorers never found it. They had to actually find it by land. And those are the kind of things I found in the historical record. And then I started going through the archaeological records. And then last time I'd mentioned we were planning a field trip. We were going to go out and get a sample from the Pajaro Gap area to try to see if the sediment would prove it came from the Sierra Nevadas. So that's where we left it last time. And so I will now continue on with the story with my new geological buddy, U.S. Geological Service Geologist Emeritus from the Tefra Lab of Moffett Field is Dr. Andrei Sarna Wushchiski. I can't say that. Can anybody say that? Can you pronounce that? Wushchiski? Yeah, so Andrei, as he likes to be called, was born in 1933 in Poland. They immigrated, I believe, through Ellis Island. He ended up going to school at UC Berkeley, became a doctor in geology, worked for the USGS. He retired over 20 years ago. He is 88 years old now. And he took me on a tour of the Moffett Field Lab of the USGS, and I got to have dinner with him at his house. And here's his backyard with his nice roses and stuff. And what's great is, this is from my last report, this is the man who wrote the paper on Lake Corcoran or Lake Clyde, when the Great Valley was a lake that the geologists believe in about 650,000 years ago, is their measurements. So he does believe the valley was a lake at some point in the past, but I came to him with all this recent, human memory information. He's like, well, that's interesting. So it intrigued him, and it intrigued him enough to, I guess since he was retired, he thought he'd humor me a little bit, or I would humor him, I'm not sure which. And so he's been working with me a bit, reviewing geological papers for me. I'd ask him questions about geology, and so it's been a really good relationship. And we went on this field trip to the Pajaro Gap, and here it is right here in the corner here. So you have the Great Valley. You go down through Suisun Bay, San Pablo Bay, and of course, if the river is running this way and this is blocked, you're then having the water run down through San Jose, Morgan Hill, Gilroy, Hollister, and then you'd be coming through the Pajaro Gap into the Monterey Bay there proper, through Elkhorn Slough or through the Pajaro River. So his theory was, hey, let's get a sample from that gap and see, we'll get about 10, 20 feet down. We will grab samples. He has expertise in actually looking under a microscope at the sediments, and he can see the volcanic glass. He's Tefra, so he's from the volcanic lab. So they studied ash layers, they studied volcanic glass. So it's his specialty area. And I was like, great, well, let's do that. And another reason why he wanted that spot is because in 1966, as a young geologist, he actually did take a core sample in the exact spot, right there at hole A. So here we have Highway 101 coming down from Gilroy, going past here, San Juan Bautista is right down here. And then there's this little, I think it's 129 that runs along the Pajaro River. And this is Chittenden. And this is a ranch right on the north side of 129. And he took a core sample right there, which they couldn't find. Apparently they threw it away at the USGS. Because he's like, hey, I took a sample there. Why don't we go just look for it? And of course, they cleaned up the warehouse. And of course, from 1966, yeah, you think they probably clean up some of that stuff, but they couldn't find his sample. So we're like, okay, let's try to get another sample. We finally got a hold of the ranch owner. We got permission to go on to the property. And this was in, August, September. And it was quite dry. It was very dry. This is the backside of the property. So that map, we had a big oxbow river that used to be there. This is that Soda Lake that was on the map. The 129 runs right through here. There's a huge granite quarry right across the river here. The Pajaro River runs right through this section here and takes a hard turn at the San Andreas Fault. San Andreas Fault runs right along the riverbed in this area. So we're on the north side of that. And we drove out here into the boonies to try to get a sample. And thankfully, my niece had just graduated from Monterey Bay. She had some muscle that also had graduated that were geologists from Monterey Bay. And she's like, hey, Elijah and Bree might want to help you. So they came along for the ride. So we had Dr. Sarna, myself, Bree, and Elijah. And this was our first attempt on the backside of the property. And if you look closely at that black blob right down there, that's black sludge. We were going down getting these samples, and it was just black goo. And we're like, what on earth? There's a lot of cows out there. I'm like, what is that, manure? It's just like, really thick or something? I'm not sure. Well, we found out later from the ranch owners, like, oh yeah, we have oil on our property. It just oozes up from the fault system. And they have tar pits and different things. So we were digging into this petroleum product that wasn't giving us much information. So we decided to move to a different location closer to the road. And here's Dr. Sarna there on the ground. We were able to get down about 3 feet. And it was just so hard. It was so dry. And we were hand cranking it. It was brutal. And we ran out of time. We're like, all right, we'll have to come back when it's moist and we can really dig in, because he did it when it was, I think, in April, when he did it back in '66. So it would have been much more moist, easier to dig out. And so we are planning to go back out in April, May to try again, as long as the ranch owner will let us come out again. So yeah, that was a good workout, by the way. I did participate. I didn't just take pictures. But it was a neat time. There's a great Mexican restaurant in San Juan Bautista. I'd recommend. They have a great back patio area, so you can check that out. Now, when I started doing more research after my initial presentation, what I found was that as I went into the most recent geological papers, they weren't even talking about any kind of theories around this realm of possibility. But as I got further back, because everybody references other geologists further back, right? So as you keep looking at papers and you find more references to other papers, to other papers, to other papers, you finally get back to two gentlemen who were having a little argument back in the late 1800s, early 1900s. And it was Branner and LeConte. And Professor Joseph LeConte, he actually proposed in 1890 that the Golden Gate was very young. There was reason to believe that the water from the Great Valley had run down the Santa Clara Valley into the Monterey Bay. And his 2 points for that were that if you look at the Golden Gate, outside the Golden Gate, there's no canyon. There's no erosion from a riverbed that's carved out onto the continental shelf. You've got the divot where the strait it is itself, and then it goes out onto a flat bedrock out to the continental shelf, to the Farallon Islands, and then it drops off. So LeConte was saying, well, it couldn't have been the outlet for that long, or else we would have had some erosion on that actual continental shelf. And the second thing he was arguing was that there were fish that were native to Sacramento Valley, like the Sacramento chub and perch, that were found in the Monterey Bay Basin and down in the Hollister Valley in archaeological records and stuff. So they were able to see that the natives there were eating these fish. And if the San Francisco Bay was just going out and it was salt water, these were all freshwater fish we're talking about. So you got a freshwater fish in the valley that also is showing up in that local area by Monterey Bay and Salinas and that area. He argued that they must have been connected at some point in the past. So that was his argument. Well, Branner in 1907 said, "You're full of it, dude, and this is why." He said, "Morgan Hill is over 300 feet in elevation. How is the water supposed to get over that ridge? Because if you go from San Jose, Santa Clara, you actually go uphill to Morgan Hill, and then you drop a bit into Gilroy Hollister, and then down into the bay. So there's this bit of a hill there." He's like, it would have drained out of like up north, out of Santa Rosa and that area, down out the Russian River or up that north area before it would have gone over the lip on the Morgan Hill. So he said, that's not possible. And then the other thing he explained with the fish was, well, the fish could have been there when the Coyote Creek's right at the top at Morgan Hill in the Santa Clara Valley, and currently it runs north. But geologically, it's run both ways because it's right on the tip. So sometimes it would go over towards the south, sometimes it would go north. So they were theorizing that when the San Francisco Bay wasn't salt water yet, it was just a valley back when the sea level was lower, that the fish swam up, got into the Coyote Creek, and then the Coyote Creek flipped and let them off on the other side, and then it flipped again, and then they were trapped. So that was his theory. Or when the water was way out by the continental shelf at the last ice age, they swam around on the continental shelf all the way around to Monterey Bay. So that was his two explanations for how the fish got there, which I think is a stretch, but that was his explanation. So that was pretty much the last time anybody argued for the Santa Clara Valley being the outlet for the Great Valley because of those 2 points, and nobody did the research until now. Woohoo! Yes. So Morgan Hill. I called Morgan Hill, the office of the city. I said, "Hey, you guys are moving up in the world, huh?" And they didn't get it, but it is true, actually. I found Morgan Hill, of course, is in the center of the Santa Clara Valley, and that's an important spot, right? The water would have been flowing right through the Morgan Hill area out into the Monterey Bay. That's at 350 feet right now. That's pretty high. It's like, how do you account for 350 feet of elevation to try to explain a way for the water to be able to go this direction? Well, I found an aquifer analysis by a geological survey person by the name of Clark. He did a survey of over 200 wells in the agricultural area of Morgan Hill, because it was all agriculture back in 1916. And he was nice enough to map out the exact locations of the wells in his report, and he gave the elevation of the wellhead. I was like, I wonder if I could compare that to today's elevation, and I can. And so what I found was that 70% of the wells around the Morgan Hill area, if you go closer to Santa Clara and San Jose, they're actually sinking. They're subsiding, they call that, because of the water drainage from the aquifer. They're actually draining the wells, kind of like down in San Joaquin. The entire ground area has sunk because they're draining the aquifer, and in some places it's down 17, 20, 30 feet in elevation. That's happening in Santa Clara, San Jose as well, but not in Morgan Hill. So they're also draining the aquifer, but I have, with the 70% of the wells that I measured, the average uplift for the last 109 years, 110 years now, is 2.87 feet. Now, it doesn't sound like a lot, but over 109 years, if you extrapolate that out without any other fancy math, you go out 1,000, 2,000, 3,000, 4,000 years, you're dropping that quite a bit. In fact, if the earliest settlers from the Native Americans, there's a 10,000-year-old settlement that they've dated in the Metcalf Canyon, really close to Morgan Hill, 10,000 years. So if you roll that clock back 10,000 years at 2.87 feet every 109 years, you drop 250 feet just with that math. And that's pretty crazy. So I have that as proof. And then NASA was nice enough to do an 8-year analysis of California. They scanned with satellites data points all over California to look for sinking, subsiding, uplifting, and that data is available online. And so I was able to look at current data, and over 8 years, it also is uplifting. So I have 2 different data points showing me with Morgan Hill that's uplifting, which means it was lower in the past. So that helps me with my proof points. The last 2 things are the fault systems there. Along the left side, we have the Sargent fault system. We have the San Andreas coming through here, and then there's a fault system through here called the Sargent faults, just on this side of the valley. And on this side, you have the Calaveras fault on that side of the valley. The Sargent fault is a thrust fault. It's an uplifting thrust fault, which again goes with the proof points. So if you have an earthquake and a substantial tectonic activity, you can take that 2.87 and potentially accelerate it, right? You roll it backwards faster because of the thrusting going up from the earthquakes. Same thing with the Calaveras fault on the right side. There was a earthquake in 1980, I think it was, right near Morgan Hill. And the report said that the Calaveras fault in that area was a left step-over fault, which tend to uplift as well. So we actually have both sides with tendencies to uplift the area. So those, again, were great data points for me to say, hey, you guys didn't even look at the information. Morgan Hill, in fact, and if you look at the valley itself, you look at the Hollister Valley and Santa Clara Valley, the sediments are very similar when you look at the well logs and stuff. So they actually call it all the Santa Clara Valley, but you have that big bump in the middle from Morgan Hill, which is something nobody's explained until now. So that'll be very, very interesting. And Dr. Strana found it very fascinating. But again, him being a geologist and me being, the historian, it's like, well, you'll have to get some more, professionals on this. I'm like, all right, well, I'll just write the book and then we'll let the professionals vet it out. All right, and this is to give you a little context for when we talked about the ice age, the last ice age. So this is, again, the geologists and their understanding of how things went. This is from Jack Meyer from our Far Western group in this area in Davis. And they have calculated, based on their studies, that at the end of the last ice age, which was, according to them, about 15,000 years ago, the sea level was way out here. So the Farallon Islands were actually on land. So this is a land bridge. This was all land here, and the water was way out here. And so as the ice melted, their hypothesis is that the water levels rose and slowly covered the continental shelf, finally made it to the mouth of the bay. This is 12,000, this is 10,000, this is 8,000. So they're saying at 8,000 years before 1950, that's what BP is, before 1950, they say the water was right here near the shoreline, and then by 6,000, it had gotten into the bay. And so that's something to think about as you see some of the other information that I'm going to be sharing. So mapping the clues, oh my goodness. This is something I have to show you in my notes page. And I'm going to have to kind of control it from over here. Oh, really? I thought I extended you. Hold on. Hold, please. Let's see. Duplicate. It keeps changing every time I do something. All right. So I'll be over here while I try to talk to it, because I have to move around and control it with my mouse, actually. Un momento, is my mouse back? Oh, there you are. All right, we got the mouse. Okay, so what I've done is all the papers, all the research I've done, I have a Google Doc that has hundreds of pages of all my screenshots, captures, notes, and whatnot. But what I've done is I've taken kind of as a synopsis to remind myself about all the different data points that I've captured on this story. And I'm not going to go through all these today, but I wanted to show a few things on my research. And for example, here's that LeConte and Branner argument, right? So we have LeConte saying, yeah, it was through the Monterey Bay, and Branner's like, no, no, no. So I put a note there. I've got my link to the actual document. I typically will put page numbers if I have the information. So that helps me kind of keep organized and visualize what I have to work with. This is one of the more recent papers I found. It's called Recent Settlements of Monterey Bay from 1968, so not quite as recent. It's actually a little older than me by a year. But what's interesting is they did profiles of all the sediments in the bay that they thought were Holocene or late Pleistocene. Holocene being from today back to 10,500 years ago, or 10,500 years ago was 1950 BP. And then late Pleistocene would be, I don't know, 15, 20,000 years ago. So they did samples to see where they thought they came from. And so they were able to say, oh yeah, well this area came from the Salinas River, which is down here. You got the Salinas River coming in through this valley here. And they said, oh, okay, yeah, this part came from the Pajaro River. And then they had some coming from up north at the Santa Cruz River, the San Leandro River, I think, or San Lorenzo, I think it is. But there was a whole two different quadrants, areas that they had checked out that they couldn't figure out the profile. They were like, yeah, the sediment's weird. It doesn't match, all these areas. In fact, it's the mineral profile shows Great Valley potential sourcing in the mix. Oh, I'm like, what? Well, I haven't heard that before. So I sent that to Dr. Cerna just recently. I keep throwing him papers and he's like, I'll get to it. But he's very meticulous, so he'll read it very carefully and he'll take his notes and stuff. So I'm still waiting patiently for him to get back to me on that. But I'm like, okay, well that's a pretty decent hint. I got somebody in 1968 that thinks that it kind of looks like Great Valley, but nah, it's not possible. But that was an interesting data point I had found recently. The other one, there's just so many. I just show you a few of them. This one here, it's called Lake San Benito San Juan. So they found when they dug there, they found clay that would have been laid down in a lake type environment. They call it lacustrine environment. And it's northwest of Hollister in that valley. And they said, hey, I think there was a lake here at some point, not too long ago. It was, I think they dated, 3,750 years before 1950. I was like, huh, well, that's interesting. And if, for some reason, if that was connected into the Great Valley, it wouldn't just be a lake here. It could potentially be a lake all the way back into the Bay Area and whatnot. But yeah, they've only focused on that local area because they, again, saw Morgan Hill and they're like, oh, well, that's the end of the lake. They didn't even think about that Morgan Hill could have been lower in the past. So that's a lot of stuff I bump into, is they'll be very focused on a local data point and they won't look at the bigger picture. Another one that I bumped into recently was go all the way down to the San Joaquin Tulare Basin, down by Kettleman City. And back in the day, there was a Lake Tulare. Everybody heard of Lake Tulare? Right? So it's been drained because of agriculture and whatnot. But in fact, it's come back a bit with these big rains. But that's a natural basin for the King River, the Kern River to drain into. And there's a ridge at the San Joaquin River, Fresno across, that the San Joaquin River is made, kind of like a dike or a levee, and it keeps the water from the Tulare Basin in the Tulare Basin, unless there's enough water for it to then overspill and then move down the valley, because the rest of the valley is actually much lower in elevation. So this paper, they looked at the shorelines. They could see the shorelines erosion on the hillsides from the old lake. And what they did was they did analysis to say, hey, back in the Holocene, again, the last 10,500 years, we believe the lakeshore at least a couple times was up at 229 feet of elevation. And I'm like, if it's at 229 feet of elevation on this side of the lake, when I look at any maps, the highest I see that levee is 210 feet. So I'm like, wow, well, wouldn't it have just filled up the rest of the valley? If it's up at 229 feet on this side, where was it on the other side? My archaeologist friend, he tended to argue, they actually did the study as well there. I met with him in Davis just a couple of weeks ago. And he's like, oh, I think they were wrong. I think it was a little bit lower than that. I think he was at 215. I'm like, well, Jeff, 215 is still above 210. So where, is it just spilling over? If it's staying at 215, you'd think the water would be at 215 on the other end of the lake, wherever that happens to be. So that was kind of an interesting data point that, again, it doesn't prove the entire valley was full, but that would be 10 feet below my house, which is at 240, which would make us beachfront property again in the Holocene. But anyway, that was kind of a fun fact that I bumped into. One of the areas that they always point to is, oh, the delta. There's been so many studies on the delta. You look at San Pablo Bay, that's on the San Francisco Bay side. Then you got the Carquinez Straits, and then you have Sassoon Bay, and then you go into your delta with the Sacramento and San Joaquin. Well, they've done a ton of studies to say, when did the water in the delta become brackish? When did the salt water, right? Because you have the melting the glaciers, you've got the ice age ending, you've got the water coming in, and so we should be able to figure out when that brackish water finally invaded the delta and started creating the type of plants that like brackish water. So they've studied seeds, and they've studied diatoms, they've studied the peat, they've studied everything. And you know what the conclusion is? Nobody gets the same answer. We've got all kinds of answers. We've got, this one was 3,000 years or less. This paper was, it didn't really kick in until 3,500 years ago. This one was 1,000 years. And they had, actually it was, that one was 1,000 BP. This one was 2,000 BP. So anyway, they're all over the board. This one actually had this was a summary of all the saline studies that had been done. So I was able to look, and they said, here's all the different ages they come up with for the brackish water, and they're just everywhere. And the one study that the archaeologist pointed me to, he's like, oh, this was a really good study. I was like, okay, I'll look it up. And this was a few months ago when I met with him the first time. I had already read that report. I had done all my notes on it. And what I found out was that they did their study on the bulrush seed. And there's different bulrush varieties. So you've got the family, and then you have bulrushes that like fresh water, you like bulrushes that really like brackish water, and you got bulrushes that are kind of in the middle. They'll take either one. Well, when they did the study, they talked about these different varieties, but when they finally came up with their dates on what they think happened, they only used the family name. They said, we're finding the family name at this date. It's like, well, you can't do that. That could be freshwater bulrush. That says nothing. That proves nothing. So, that's the kind of stuff I'm bumping into. You'll get people who have grants that have to write a paper, maybe it's their dissertation, they have to come up with something, and you'll read the abstract, and it sounds good, but once you start looking into the actual data in the report, which is what I have to do, I'm reading every single bit in it. I'm looking up, scientific names, I'm looking up really fancy terms, and you find out that, no, actually their study was bogus. That didn't prove anything from a saline perspective. So that's the kind of stuff you bump into. It gets pretty crazy. All right, let's see. There's just so much. The buried archaeological sites. So the archaeology team has found, I want to say hundreds of buried sites. It's at least many dozens of buried sites. So there's archaeological finds that they have. There's a village or some kind of settlement, and then they'll find it buried under 1, 4, 10 feet of soil. So there's been a deposit that could be a flood deposit. It could be like a river's just been depositing stuff on top of it. But some of these sites are buried under 10 feet of soil. And so people live there, and then they ended up, that site got buried by some kind of either major event, or they left and it got covered with river deposits. So, but there's so many of those. The entire southern Bay Area has lots of buried sites. The San Ramon Valley, right up here through Danville, San Ramon, whatnot, buried sites all the way through there along the creek. And nobody has a good explanation for all these different sites up in Santa Rosa, all kinds of places. It's pretty crazy, all the buried sites they've found. And the reason that's important is that when I go talk to our archaeologist friend, and get back into my presentation. Is it working? Yay. Oh, that's next. I'm sorry. I'm jumping ahead of myself. I'll get to him next. But first is the clay. Oh my goodness, I forgot about this. So when you have clay, it's the finest sediments, it's the very fine stuff. It floats in the water the longest. Not until the water is still will it settle down. So if there's any kind of disturbance, it'll be floating around in the water, and it'll finally settle. So it'll be a lake, a marine environment, at the end of the water line. And so when you have clay, you've got some sort of water system that has deposited that, and it has, if it's in a clay layer, that means it's either a floodplain or a bottom of a lake or a marine environment. Now, hints in the data, I found blue clay in some of the well logs, and I was like, oh, that's weird. And I started looking up blue clay, and why so blue clay? Well, blue clay happens by a couple of different ways. You can either have some kind of blue rock that has degraded and kept its blue hue, and then it gets deposited with the blue clay and the other sediments, so you end up with blue. But the more common way that you get blue clay is that the clay has iron in it. That iron goes with the clay, gets deposited in the bottom of a lake. It's a very low oxygen environment. So what happens is the bacteria need oxygen. And so they'll actually steal oxygen molecules from the clay, the iron in the clay. So the Fe, the iron molecules, will lose an oxygen. So it'll go from Fe3, which is your oxidized variety, to Fe2, which is reduced iron, and it turns blue. So once you expose it to air again, to oxygen, it'll actually start rusting and oxidizing very quickly. And my archaeologist friend has seen this. They've been digging, and they'll hit blue clay, and they drop it off to the side, and very quickly it turns gray and starts oxidizing and changing color. So that's a clue that there is potential lake environment or a marine environment where you're seeing blue clay. Well, let me show you my other map. Because what I did was, I went to the USGS's site. I found we have 43,000 wells that have been dug in California. And every well driller has to do a well log. He has to say, okay, I hit clay at this level, sand, silt, gravel, bedrock, whatever it happens to be. And depending on how good your driller is, he will describe it better. The lazy ones will do clay, silt, sand. Some of them will do brown clay, red clay, green clay, blue clay. They'll put color on it. And so what I did was I went through the lithology. They actually have a database of all these wells. They mapped out the layers with the types of sediment they found. And I was able to create a data set to then put that on a map. I actually mapped the wells where they were at. And this is my map. So you can see the Sacramento Valley, and get this is a subset, right? We have 43,000 well logs. I would say the majority of the people just did the simple logging. Like I've manually looked through well logs and they'll say clay. They won't say blue clay. So these are just the ones that say blue clay. These are just the ones that have blue clay from 0 to 100 feet in depth. Because there's blue clay down at 500, 600 feet. I don't care about that. I'm looking for something more recent, right? So I just took blue clay logs from the top 100 feet of sediment and I mapped those. And this is what I got. So you can see the entire Sacramento Valley is just completely covered in these blue clay logs. You can see it's just massive down here, down in the San Joaquin Basin. What's interesting is you'll find it in other areas that are intriguing. So you'll go up these valleys. This is Gonzales here. So this is the Salinas Valley. So they're finding blue clay like all the way up to here, which I thought was very interesting. So I actually mapped all those, and this is again a data point. It doesn't prove that this was all a giant lake, but it is a data point that says, hey, we have clay, it's blue, so there's a few ways we can get the blue clay. So I would say that perhaps geologists, we need to revisit this data point and see if perhaps there's some information here that people are ignoring. So that's something that I did, and it's just a crazy visualization to then look at the, here's Monterey Bay area, here's the Santa Clara Valley, here's Gilroy, right in the center part. And the different colors are just different data sets that I had found. So, and I had to break it up into smaller chunks so that Google My Maps would map it. But that was a really crazy aha moment when I found that. All right. Try to wrap it up here. So Far Western Archaeological Group, this is the archaeological group out of Davis that was nice enough to meet with me a few months back. I told them about my initial, discoveries and theories, and they were like, wow, that's interesting. And Jeff Rosenthal has been, very open-minded. He's like, well, yeah, maybe, 11,000 years ago or something, but I don't think it was, last 5,000 years or something. So he was open to it possibly being available, but wasn't so sure about the data points. But the funny thing is, when I met him the first time, he's like, hey, you know what? We found something in San Jose that we've been scratching our heads about, and you just rang a bell for me. Like, let me share this with you. This is a map of San Jose. Highway 101 is right up here. I think this is the 280. Yeah, this is the 280. And this is like Main Street in San Jose. What they were doing is they were building a BART tunnel. So with Caltrans and any kind of big infrastructure things, they don't want to dig up an Indian burial. Not a good look. And what they do is they always have an archaeological team come in and go, hey, we want you to assess the area, make sure there's no archaeological sites here that we're going to damage or disturb. And in this case, they were like, hey, we're making a tunnel. So we just want to know how deep we have to go to be underneath any kind of human occupation. All right, so they're like, okay, well, yeah, we can do that. So we're going to core. They cored all along this corridor. They took cores, They did analysis of carbon-14 dating. They looked for paleosoils, which are different soil layers. They looked for, of course, for anything archaeological. And what they came up with was very interesting. This is an ancient river channel. This is the west side of the San Jose tunnel area they were looking at. Here's the different core spots they did along that long line on that road. So this is straight across the valley, the Santa Clara Valley. And what they found was, so they're looking at Holocene being 10,000 years ago. So they were looking for carbon-14 dates down these cores. And what they did is they found that the Holocene ran on this line here. So all this white area was deposited during the Holocene, which would have been during potential human occupation. And what's interesting is it looks like an actual river valley. And they were completely shocked by that because they were like, wait a second, here's Coyote Creek, here's the Guadalupe River. There's not enough water coming off of Morgan Hill and the different areas around there to make a channel that wide and deep to be able to explain that big channel. And he's like, well, your theory actually might go with that. I was like, well, yeah, I think so. I'd like that. So this is amazing for them to share with me. And they did this is in their report to the folks at the BART system, and they were gracious enough to share it with me. But this was mind-blowing, actually. And this line right here is actually a buried soil. So what they found was this is all kind of river filling up area, the channel of the river filling up, and then it settled at about 6,500 years BP. There's kind of a soil that develops. So you'd have roots, you'd have dirt, leaves and stuff. So you ended up with a little layer there that they were able to date. And then it filled up again after that. So some really interesting data points for me to digest on and of course share in the book as a potential evidence of this actually happening. So there's so many other things I've found, but I just don't have time to cover everything. And it'll be in the book when it becomes available at some point in the future once I get done with it. But we're looking to get samples again from Pajaro Gap. I actually have communication with a well driller in Watsonville. They seem to be open to, next time they drill a well in the area we're interested in, potentially getting me samples. I was like, hey, just give me some snack bags of soil from the different layers in your drill operation. You're digging it up anyway. I just need a little bit of dirt. And then hopefully I can get Dr. Sarna and our team to look at that sediment and see if it has any Sierra Nevada provenance. Because if it does, and it's down in the San Juan Bautista area, Gilbert Hollister, that's a huge data point to prove that, in fact, the water fairly recently was running through there instead of through the Golden Gate. The possible samples in the San Ramon Valley, they have some aggregate companies in there that are doing sand and gravel and whatnot. So I'm going to see if I can get a sample there because, again, those buried archaeological sites, I was like, well, maybe the Carquinez Straits was closed too. And maybe the water was running through the San Ramon Valley and out through like Niles Canyon. So that's another area that's kind of on my back burner. It keeps expanding. It's like, whoa, wait, what about this? Hey, the Russian River. Whoa, what about that? It's been getting kind of crazy. But one last thing that I forgot to show you as we're wrapping up here, Dr. Sarna brought up that he was born in 1933, the year the Golden Gate Bridge was started to build. And so he's always been fascinated with the Golden Gate Bridge. And a couple of things that he mentioned, he's like, hey, Mark, you ever looked at the old pictures? So this is Fort Point. That's underneath the Golden Gate right now. You have the Golden Gate running right over the top of this. So this is a picture before the Golden Gate. And you can see this huge landslide scar across the way. There's actually 3 of them. In this picture, you can only see one of them really, but there's 3 huge landslide scars. And Dr. Sarno was like, you know what? Nobody's ever looked into that. If that was actually a mountain range across, and that's the scar from when that opened up, we could potentially get samples from that landslide area, and we can figure out when it started getting solar radiation exposed. I was like, really? Okay. So they could potentially tell you how old that landslide is if we can get somebody interested to go do that. So that was interesting. And this is the other picture of it that shows it a little bit better. So you can see this is a modern picture. So you got this big scar right here. This is bedrock, by the way. This isn't a sandy hill or something like that. This is actually part of the bedrock that's opened up as a landslide. You've got the scar over here as well, and then here's the giant scar right next to the Golden Gate. This is a huge area that, again, the mountain's missing, but people have just kind of theorized that, oh, it must have been erosion or something, right, when the water came through. But that could potentially be scars from when the Golden Gate actually opened. When Bancroft said it opened, when the tribal stories said it opened. So we are excited to continue the journey, and I want to provide an update for folks. And if you have any questions, of course, we can get into that afterwards. But with that, I will wrap it up and have David like, subscribe, join our YouTube channel, please. And that's a wrap. Good? All right. Thank you. Any questions?